Okay, students, from today class we will discuss regarding design of columns. Okay, so before going to design of columns, let me ask, how many students have seen columns? Raise your hands. How many have seen columns? Okay. Where columns are used? Anybody? Where columns are used? What is the purpose of this column design? Columns. Huh? What kind of loads?
Self load and light loads.
How load is transferred from to the columns? How load is transferred to columns? Beam load is transferred to column. How the load comes to beams? Huh? How load comes to beams? Where the load come from beam? From roof slab. So from roof slab, the load will be transferred to the beams. From beams, the load will transfer to columns as forces and moments. So what are different shapes of columns you have seen? Anybody? Rectangular,
Square.
anything else? There is no other type columns, shape wise. Polygonal, not octagonal. It may be hexagonal, maybe octagonal, maybe pentagonal, depending on this, it may be. So different polygonal columns. Okay, sit down. So generally column is called as a compression member. We have already studied design of different tension members. Column is a compression member. Okay, and if you see a column, generally in a building, if you try to see a column, the columns will be just like this, the reinforcement detailing. If any column is there, there will be column base. Okay, column will be rest on the footings. Okay, column rest on footings. Then this column, this is a square column. Okay, and these are the main reinforcements. These are the main reinforcement or longitudinal reinforcement, and to keep this in position we have provided the ties. These are called the lateral ties. Okay, so anybody can draw its plan and elevation, sectional plan and elevation. Anybody can draw? Come to blackboard. Draw the section and elevation of the column. Okay, basically he has shown this reinforcement detailing, but you can also show size. You have to modify slightly this. This can be modified to a some extent to get the right kind of. Now he has shown only this, but this will be look like this, not like this. there is a column first, then inside that there will be reinforcements. So this is the main reinforcement, and these are the lateral ties, and these are the 4 bars, the main bars or the reinforcing bars, main bars, and this is your link or lateral tie. Now if you draw the elevation, this line will look like this, these rods, 1, 2 rods will like this, these 2 rods will look like one line, and these links will look like one line. If you see this model, if you look from the front side, what will look like? If you from the front side, what will see? Only you can see this bar, you can see this bar, okay, and these bars will just look like one lines with the proper spacing. So this is generally lateral ties. Sometimes also you can use the helical ties or these like spirals. You can also use the spirals like this way. This can go like this way. So these are the helix or helical reinforcement. So columns are the compression members. Columns are basically compression members subject to axial loads, and also sometimes they are subjected to moments. So depending on the type of loads, you can talk axial loaded columns, you can say uniaxially moments and biaxially moments. The 3 conditions will come. The column may be subjected to axial loads, so a column may be subjected to axial load P, the load is acting along the axis, so this is called axial loaded column. Now sometimes the load may be at an eccentricity. Instead of central line, this will act here at an eccentricity E. So this will called uniaxial loaded columns. That is called uniaxial loaded columns. Or subject to uniaxial moment. So this can be equivalent to one load acting here plus a moment P into E along the axis. So this is called uniaxially loaded columns or uniaxial moments. Sometimes you will find also biaxial moment. Biaxial moment will come in case of, suppose this is a building and you have number of columns here. You have a column here, you have a column here, you have a column here. Now suppose there is a building and you have 9 columns. In these columns, these end columns C1, C1, C3, C7 and C9, these columns are biaxial loaded columns or biaxial moments. What is it? Biaxial moments or biaxial? biaxial bending, subjected to biaxial bending, subject to biaxial bending, and this was uniaxial bending or uniaxial bending, you can say uniaxial bending moment. So uniaxial bending and biaxial bending. So now these four columns C1, C2, C1, C3, C7 and C9, they are subjected to biaxial bending. Bending will come both axes. How it will come? This is a beam here and this is a beam here. So these beams will be treated as fixed ends, and if you take both ends are fixed, now here will a moment and here will a moment. Moment will come from the both axes. That is why it is called a biaxial bendings. Okay, moment will come both sides. Now if you come to these columns C2, C4, C6 and C8, these columns are uniaxial bending. What is uniaxial bending? Uniaxial bending means, suppose this is the column. How a moment will be here? This will consider like this, and this is considered like this. Now this moment will come here, this moment will come here, and here also you have a moment. Now these two moments will cancel each other, and you have only one moment. That is why these columns are subjected to uniaxial bending. Now if you come to column C5, in case of column C5, what you see? Moment is coming from this side, moment coming from this side, moment coming from this side, moment coming from this side. All these four moments will cancel with each other, opposite to each other, and you have only you will get the axial load. So this column will be axially loaded columns, axially loaded. C5 will be axial loaded column, okay, and others like that. So these three category columns you have to design. Generally in the field practice, the periphery, the end columns or corner columns are subjected to biaxial bending, other periphery columns are subjected to uniaxial bending, and the interior columns are subjected to axial loads. Okay, so we will discuss about axially loaded columns, how to design the axially loaded columns as per the codal provisions. Okay, how the code says. Now before going to that, let us go to the code. Open your page number 70. Now you see clause number 39. Now clause 39 gives limit state of collapse compression. Design for compression will find clause 39. What the clause 39 says? First the assumptions. For the analysis and design, you have to do some assumptions in design. What the assumption it says? Read that. In addition to the assumptions given 38.1a to 38.1d for flexure, the following shall be assumed. That means whatever assumption we have considered for bending or the flexure design, the same assumption will remain valid for compression members. Okay. In addition to that, there are two other conditions given which will be assumed. What is the first condition? The maximum compressive strain. The maximum compressive strain in concrete in axial compression is taken as 0.002. So that means the maximum strain, as you have seen, the maximum strain in bending in compression was 0.0035. Now here in case of axial, this value is 0.002. This is the maximum strain. Beyond that it cannot go. Okay, that is the maximum strain, that is the assumptions. Then there is another clause, the maximum compressive strain at the highly compressed extreme fiber in concrete subjected to axial compression and bending. The two cases we have seen. One is columns are subjected to axial compression. Number two, axial compression plus bending. Bending may be in one axis, bending may be in both axes. That are the two cases. So for that case, when it is subjected to axial compression plus bending, what will happen? The maximum compressive strain at the highly compressed extreme fiber in concrete subjected to axial compression and bending and when there is no tension on the section shall be 0.0035, because 0.0035 is the maximum strain in bending, in compression. So that strain minus 0.75 times the strain at the least compressed extreme fiber. So one fiber will be maximum compression, one will be the least compression. So then what the value of the compression of strain there, that will be 0.0035 the maximum fiber minus 0.75 times the least compression fiber. Okay, that is the things. Now then we call out minimum eccentricity. What is minimum eccentricity? Minimum eccentricity. Minimum eccentricity means, suppose you think the axial load means what? The axis of load and the CG line of the column coincide. That is the meaning of the axial loaded column. Axial loaded column means you have a center of gravity line of the columns and you have a line of action of the load. The line of action of load and the center of gravity of the column section are both coincide. That is called axial loaded. But in practice, in the field, while you do the constructions in columns, the CG line may not be exactly straight line. Why? The CG line may not be exactly straight line because there will be irregularities in material, there will be irregularities in compactions, there will be irregularities in placement, formwork slightly maybe here and there. Okay, so these things leads to the minimum eccentricity. Though we call it a axial loaded column, but still there will be some eccentricity is permissible. If it is slightly eccentric, it is also called as a axial loaded. If the eccentricity is within permissible value, then we can design it as a axial loaded columns. Okay. So what it says, all members in compression shall be designed for the minimum eccentricity in accordance with 25.4. What is 25.4? Where calculated eccentricity larger, the minimum eccentricity shall be ignored. Okay. So 25.4, what the page number? Okay, for page 42. Now this is the minimum eccentricity. What it says? All columns shall be designed for minimum eccentricity. So it may not be exactly coinciding. There will be slightly deviation of the axis and this CG of the loads. So all columns shall be designed for minimum eccentricity equal to the unsupported length of column. Suppose you have a column as height. Length means what? The height of the column supported between two floors. Okay, between two floors you can say from this beam to in the ground floor there will be a column. So column length, unsupported length of column by 500. What it says? Plus lateral dimension. Unsupported length by 500 plus lateral dimension by 30. So this is the minimum eccentricity. You have to calculate minimum E value. Unsupported length means suppose you are taking a column has two dimensions. One is the B value, one is the D value. B and D, they are called the lateral dimensions. These are called the lateral value. Lateral dimension. Okay. So length of column you know, then unsupported length by 500 plus lateral dimension by 30. Okay, that you have to find out. Subject to minimum of 20 millimeter, and there is minimum is 20. Where biaxial bend is considered, it is sufficient to ensure that eccentricity exceeds the minimum about one axis at a time. If you are taking biaxial bendings, then one side must exceed the value. Okay. So this is how to check the minimum eccentricity. So minimum eccentricity can be calculated, and the value is minimum is 20 millimeter. Okay. So once you calculate minimum eccentricity, then you can call it as whether it is a short column or long column. The columns can be called as short column or long column. That is again codal provision is given. You can go to the next pages. What is a columns, long column or short column? Okay, clause number 25. Compression members. What is the definition of a compression member? You can see here. What is a compression member? Column or strut. Column or strut is a compression member, the effective length of which exceeds 3 times the least lateral dimension. So, if the length by least lateral dimension exceeds, that means greater than 3, then it is called as a column. If length by least lateral dimension exceeds 3, it is called a column. So you have 2 dimensions, one is the width, one is the depth. So out of this, the least value will consider, that is known as the least lateral dimensions. Now once the least lateral dimension length ratio by this exceeds 3, it is called a column. If it is less than 3, if this is less than 3, it is called a pedestal. If less than 3, it is called a pedestal. So compression members can also be strut. What is a strut? Strut is a technical word used for what? Compression members in the trusses. In case of trusses, you have either tension members or compression members. Tension members are called ties, TIES ties, and compression members are called struts. Okay, so that is why it is written columns or strut is a compression member where the effective length of which exceeds 3 times the least lateral dimension. Okay. Now what the next clause says? Short and slender compression members. Whether it is a short column or a slender column. So column can be divided in 2 parts. One is the short column, or it is called as a slender column, slender or long column sometimes. So short column or slender column. How define the slender or short column? What it says? A compression member may be considered as a short when both slenderness, so both, not one, when both slenderness ratio LEX by D and LEY by B are less than 12. That means what you are finding, your length by least lateral dimension is less than 12. If this value is less than 12, then it is called as a short column. If it is more than 12, it is called as a slender column or long column. So all the values are given here. What is LEX? LEX is the effective length in respect of the major axis. D is the depth in respect of major axis. LEY effective length in respect of minor axis, and B is the width of the member. So all the things are given, and if this value both LEX and LEY divided by B and D is less than 12, then it is called a short column. More than 12 is called a long column. Now once you first you have to decide whether it is a short column or it is a long column. To know it is a short column or long column, if dimensions are known, then you classify. Then analysis or design will be done separately for long column, separately for short columns. So we will start from the short column. What is the strength of a short column? Again go to page 71 of the code, clause 39.3. So see clause 39.3. Short axially loaded members in compression. The members shall be designed by considering the assumptions in given 39.1 and the minimum eccentricity. When minimum eccentricity as per 25.4 does not exceed 0.05 times the lateral dimension, the member may be designed by the following equation. So before using the analysis of the short column, you have to check that what the minimum eccentricity value that you have calculated by unsupported length by 500 plus least lateral by 30 does not exceed that means shall be less than 0.05 times the lateral dimension. That means 0.05 times the depth or 0.05 times the width, that you have to check. Then you can use the formula that is given, your capacity ultimate load is equal to 0.45 FCK into AC plus 0.67 Fy into ASC. So what does it mean? All the nomenclatures are explained on the code itself. PU is the axial load of the member, and FCK is the characteristic strength of the concrete, and AC is the area of concrete, Fy is the characteristic strength of the compression reinforcement, and ASC is the area of longitudinal reinforcement, not the ties. It is the longitudinal reinforcement, that means main bars. Okay. Now how to find AC? If you know the area of the section, if you know the size of the section, then you can find the gross area. That means you have to find the gross area. What is the gross area? Gross area is equal to, suppose, AG. If it is a rectangular column, multiply width into depth, that will give the gross area. If it is a square column, multiply a square of the sides will give the area. If it is a circular column, pi by 4 into d square will give the area. So you can find out the gross area of the column. Okay. Gross area minus steel area will give the concrete area, AC. Basically AC can be obtained. AC, concrete area is nothing, gross area minus steel area. Steel in compression, you can subtract this steel area from the gross area to find out the concrete area. Okay. So in an analysis problem, all the dimensions will be given. Okay. All the dimensions are given, you have to find the load carrying capacity. There are two kind of problems. One is analytical analysis of the load carrying capacity of the column. Second category is the you have to find the dimension steel and the steel area of the column, design. One is the analysis, second is the design. While doing the analysis, all the data, what the data? Data is the size of column will given, area of steel will given, grade of concrete and steel will given. Only you have to put the formula and get the result, provided it is a short column. Okay. Now reverse is, the load will given, you have to find design the column. While doing the design part, the load will given, you have to design the column. Design the column means what? Design means you have to fix the dimension and you have to find the area of steel. Design means you have to find the dimension of the column and the area of the steel. Analysis means area of steel will be given, section will be given, you have to find the load carrying capacity. These are two type of problems you will face. Okay. In case of a rectangular short axial loaded columns with lateral ties, not helical ties. This is very specific. This formula he has very categorically written. This is for axial load column with lateral ties. Okay. If it is helical ties, there is a different things are given. So this is the only analysis part. That means if you will given a small size. Suppose you are given. Suppose a problem is given. The size of column is given. Size is given 400 into 600 millimeter. Size of column. Then it is given FCK or M20 and FE415 is given, and number of bars 4 numbers 16 5 bars as reinforcement, as longitudinal reinforcement. So find load carrying capacity of a short column. short column with lateral ties. Now you do this problem. What is given? Just two calculations. This is the data given. Size of column is given 400 millimeter into 600 millimeter. Gross area M20 grade of concrete, Fe415 grade of steel, and reinforced with 4 number 16.5 bars as longitudinal reinforcement. Find load carrying capacity of a short column with lateral ties. So this is the analysis problem. You just calculate by your calculator what is the value coming. Simple, put this formula. FCK is given, then ASC is given, AG is given. Find out AC, and find the load carrying capacity. Do yourself, quick. Calculate the value. What is the value? 2137. So you are finding 2137.18 kilonewton. So all are getting the same answer. Anybody has a different answer? So simple, put gross area AG is equal to 400 into 600 millimeter square. Then find out AC, that is equal to AG 240000 minus AC is 4 number 16. So 4 into pi by 4 into 16 square. This comes out to be 804. So minus 804. So find the AC value. Then put all the values here and just put the formula, get the answer. So this is the load carrying capacity of a short column with lateral ties. Now this is a simple analysis part. All the values are given, put the equation and get the answer. Okay, that is nothing. But design part, you have to find some things, how to design. In the design case, it will give in design for 1000 kilonewton load, design for 2000 kilonewton load, and you have to choose all these things. You have to fix the dimensions, you have to fix the steel area. So you go to your code page number 48. Page 48 in the code gives the column design procedure. How to design columns? Go to your page number 48 of this IS 456. Clause number 26.5.3. So go to page 48. See the column design procedure. What is written there? So in columns, we have two kind of reinforcement. One is the longitudinal reinforcement. Second is the transverse reinforcement. Transverse reinforcement may be in the form of lateral ties or in the form of helical ties. Okay, the two kind of things will come. So either you will provide the lateral ties or the helical ties. Okay. Now what it says, how to find longitudinal reinforcement. Code is very clear. What it says, the cross sectional area of longitudinal reinforcement shall not be less than 0.8% nor more than 6% of the gross cross sectional area of the column. That means as you have seen, what we have seen? We have seen AG is equal to AC is equal to AG minus AC. Okay. So if you will find the area of steel is some percentage of the gross area, then you can find out AC in terms of AG. Are you getting my point or not? Your equation is given very clear that PU is equal to 0.45 FCK AC plus 0.67 FY AC. Now if you will convert AC and AC in terms of AG, gross area, then you can find the gross area and you can find the dimension of the column. To find the dimension of the column, you should know the gross area. So to find the gross area, you can assume the area of steel is a percentage of the gross area. If you find the area of steel is a percentage of gross area, then you can find out the concrete area is also a percentage of the gross area, and you can put here find AG. So that is why code, what code says, you can assume the value between 0.8 to 6. The minimum value shall not be less than 0.8 and you can go for the up to 6%. There is a note written. What is the note? the use of 6% reinforcement involve practical difficulties in placing and compacting concrete, hence lower percentage is recommended. So you will always assume the low percentage of steel. You may take 0.9, 1%, 1.5%, but you should not go for 4, 5, 6%. If you go the higher percentage of steel, then you will face the practical difficulties in placing and compacting concrete in the site. The problem will come in site. If you put more reinforcements, your vibrator needle may not enter inside the things, or the your aggregates may not enter inside the steel. So there are no proper bonding between steel and concrete. That is a practical difficulty. That is why it is recommended that higher percentage steels should not be used. You should use lower percentage of steels. Okay. And usually the percent steel shall usually not exceed 4%. So maximum, though it is written 6%, generally don't go for 4%. If anybody has done the design in Start Pro, if you will find the design percent of steel coming 6%, 8%, then the design will not be accepted in the packages. So they have go maximum up to 4% of steel. So while you are doing, go for the lower percent of steel, 1%, maximum 2% steel. Okay, don't provide more steels in case of columns. Then what the recommendation next? The minimum number of longitudinal bars provided in a column shall be 4 bars in rectangular sections and 6 in circular column. If we are designing a circular column, the minimum number of bars to provided is 6. If we are designing a rectangular column, the minimum bars shall be 4. Okay. If in your design the number of bars is coming 3, can you provide 3 number bars for a square column? Answer is no, because though the design value coming 3 or 2, but minimum will provide 4. At each corner minimum 1 bar should be provided. Similarly, in case of a circular column, the minimum number of bars should be 6. If you are getting 4 bars, 5 bars in the design, but you have to provide minimum 6 bars. Okay, more than this it is always accepted. Now next, what is the diameter of the bars? The bars shall not be less than 12 millimeter in diameter. In case of columns, the minimum diameter of bar is 12. You can provide 12, 16, 20, 25, 28, 32, 36 like that way. But you cannot provide bars like 8 mm, 6 mm, 10 mm. We are using 8 mm, 6 mm bars in slabs and beams, but we cannot use in case of columns as a main reinforcement. Then next, a reinforced concrete column having helical reinforcement. If I use helical reinforcement, whether it is a circular column or rectangular column, the minimum number of bars will be 6. Read that clause. A reinforced concrete column having helical reinforcement shall have at least 6 bars of longitudinal reinforcement within the helical reinforcement. You cannot provide less than 6 if you are using a helical reinforcement as a ties. Okay, so whether it is a circular column or it is a rectangular, it does not matter. If you are using a helical reinforcement, you have to provide minimum 6 bars. Okay. Next, what is the spacing? The spacing of longitudinal bars measured along the periphery column shall not exceed 300. What it says? If you are getting the number of bars shall be equispaced along the circumference. But in no case it shall not exceed 300. The spacing of the bars along the periphery of the column in case of a circular column or in a helical reinforced column shall not exceed 300 millimeter. You have to find the spacing. Suppose this is your diameter. Suppose this is a column. Okay, and you have the reinforced like this way. This is your ties and you have provided bars here. So this distance, this spacing shall be less than 300. You will find the spacing of this reinforcement of this longitudinal reinforcement shall not exceed 300 millimeter. Okay, that is the thing you have to check. Now, what the last thing is telling, in case of pedestals, as you have seen what is a pedestal, here you see the note is given. What is the definition of pedestal? Pedestal is a compression member, the effective length of which does not exceed 3 times the least lateral dimension. Very clear. The definitions are also given in the code. Now, What is the percent of steel? Pedestals are not designed. Remember, pedestals are not designed like columns. If pedestal means what? Pedestal, what is the meaning of pedestal? Stage, victory stands, pedestals where you stand, take your prize like that, pendals like that way. Pedestals, in case of pedestal in which longitudinal reinforcement is not taken into account in strength calculation, nominal reinforcement not less than 0.15% of the cross sectional area shall be provided. So minimum steel to provide in case of pedestals, don't design. If you are going to construct a pedestal, give a minimum steel 0.15% or more, 0.2% like that way. Don't design these pedestals. And pedestal is nothing, it is a compression member. Pedestal is a compression member, the effective length of which does not exceed 3 times the least lateral dimension. So now what do we think? 3 things. One is the column and one is the pedestal. There is a clear distinction between these two boundary line. The effective length by least lateral dimension less than 3 is called a pedestal, more than 3 is called a column. Again, column is divided in 2 categories. One is the short column, slender column or long column. And again the boundary is the effective length by least lateral dimension is less than 12, more than 12. Okay. So that is the only thing you have to first confirm for before design. Next comes transverse reinforcement. How will provide the transverse reinforcement? How to provide the transverse reinforcement? Lateral ties. The code is given. The ties means when you provide the ties here. When you are providing ties here, what are 2 things? These are the lateral ties. Okay. It has a diameter and this is the spacing. That is called pitch. That is called the pitch. So for designing the lateral ties, there are no calculations. You have to follow the codal provisions. You have to find the diameter of the ties and the distance between the center to center of the ties. That is called the pitch. This is the pitch values. Okay, you have to find the pitch and the diameter. What it says? What to find diameter? First see the diameter. What is the diameter? The diameter of the polygonal links. The diameter of the polygonal links or lateral ties shall not be less than 1/4 of diameter of the largest longitudinal bar. In a column, it is not always same bars. You can give a combination of bars. 20 mm bars, 16 mm bars. 20 mm bars, 25 mm bars. Not 25, 16. Consecutive bars are given. Okay, 25 mm, 28 bars. That's why it is says the diameter of the polygonal links, all lateral ties shall not be less than 1/4 of the diameter of the largest longitudinal bar. See the diameter of the bars for the largest value, 1/4 of that value. No case less than 6 mm, not 16. No case less than 6 mm, it is not 16, it is actually 6. So you have to take 6, a minimum diameter of the links 6. But in the market, it is available 8 mm. In the market, we are using Torr steel or HYST bars. The minimum diameter available in the market is 8 mm. Generally, we use the 8 mm bars are the links. Okay. Then what is the pitch? The pitch of the transverse reinforcement shall be not more than the least of the following. Least. Out of the 3 value, which is the minimum, that is the least value. What it says? Least lateral dimension of compression member. Least lateral means, suppose in this case 400 and 600. Least is the 400. Okay. Then 16 times the smallest diameter of longitudinal bars. So in that case, least is 400 millimeter. Then comes 16 times diameter of bars. We have taken 16 mm, 16256. Then 300. Out of these 3, whichever is the least. Suppose you are designing a 400 by 600 column, then you have used 16 mm bars as the reinforcement bars. Then how to calculate the pitch? One is the least lateral dimension. You have 400, 600. Out of this, take the minimum value. 16 times diameter of the bar, 256. Then 300. Whichever is the least. Least value is. So now you can say provide 8 mm bars. 8 mm bars at the rate of 250 millimeter center to center. That is your pitch. So pitch means you provide the spacing between 2 bars. Okay. So this is the design procedure. That means if the column load is given, you have to assume a percentage of steel and find out the gross area. Once you find the gross area, then you find the size, is it rectangular column or a square column or a circular column, find the size and then provide the steel. That is the basic designs. But how the links are provided, if you see the links, there are many types of lateral ties. You can see now here, single tie, 2 ties, 3 ties, 4 ties, many ties are given here. You can see the ties, how the ties are provided in case of columns. These kind of constructions you have seen in the field, if you go to the field in the multi-story building being constructed, when there are 4 bars in the 4 corners, there is a single tie. The tie moves like this way. Suppose these are the 4 bars. Now the bars will start from here, it will go around this, 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 then it will go like this way. These hooks are really, these are some dimensions. So that will be properly keep this position. Minimum 8-5, that will see lateral stress. You see how the reinforcement is put there here. You can see here single tie. There are only 4 columns, 4 rods, 1, 2, 3, 4. Now your 1, 2, 3, 4, 5, 6. This distance is less than 75. If the distance is more than 75, then you have provide here another ties. So if it is more than 75, the distance between 2 ties, or distance between 2 main reinforcements, if it is number of bars are more, you have to see the spacings. If the distance between 2 main reinforcement is less than 75, where number of bars are provided, then you have to provide the extra ties. Suppose there are 8 rods. How the 8 rods are being tied, you see how they are tied. Okay. So when there are more, suppose you will get here more another 4 rods. Then you have to also put these rods into, you have to put all these rods into properly held in position. The purpose of the lateral ties, what the purpose of lateral ties? The lateral ties will keep the main bars in position. If you will not keep the main bars in position, while putting the concrete and compacting the reinforcements, they may be displaced. You may not get the exact size of the things. The formwork will be disturbed. Okay, that is why you put this kind of ties. So in the next class, we will discuss about design part of the columns. So what we discuss, that what is a compression member and what are the classification of compression members, how the codal provisions are used for analyzing and designing the axially loaded short columns with lateral ties, and you will also get axially loaded columns, short columns with lateral helical ties. That will again codal provisions are there. Okay. So with this we conclude this class, and next class we will go for the design part of these things.